Hi. So in this video, I wanted to go through how one goes about making like a parametric part from a custom off-the-shelf or commercial off-the-shelf part, the COTS part. So for this example, I'm going to be importing a T-slot that I pulled off of McMaster car. So I will go and grab that here real fast. And you can get this part off of my GitHub page linked in the description here, or you can download it from McMasterCard. This particular part I'm using is McMasterCard's 47065 T411 T-slot framing, 1-inch, 1 foot long, silver anodized. Just pretty standard T-slot. So we brought it in here, and you can see it's a pretty lackluster, pretty standard T-slot. And the goal for this is to parameterize the length of this T-slot so that you can just modify one value and then save this file off as a custom part to put in your assemblies or whatever, so that you don't have to go back and continuously edit or import these parts. So to start off with, we've got to get rid of the 3D geometry of this T-slot because we only need the 2D cross section since it's an extrude and it is consistent all the way along. So in order to do that, I'm going to come over here and I'm going to switch to the draft workbench. And now that we've switched there, I'm going to look at the center point, and looks like the origin for this part is kind of right in the middle of it, which would make sense. So I'm going to move this part up by that amount. So we come down here to position, and we need to move this part in the Z direction, 1/2 of a foot. So this would be 6/24.5. Let's see. This is in millimeters. I was going the wrong direction. So we need 6 times 24 or 25.6. And there we go. You can see that this is now sitting right on that plane, or pretty close to it. It doesn't have to be exact. It doesn't matter all that much. And if you're wondering here, this plane is supplied by the draft workbench. So if you have the draft workbench loaded, you can see this plane. And if you close this part and you open it again, this will disappear until you reload the draft workbench. And if you want to turn it off, there should be an off button available somewhere in one of these menus. Let's see. I believe it is this one. So you click this button and that grid goes away if you don't like that grid. We'll just leave it on. It's not like it's hurting anybody. So I will grab this bottom face, and what we have to do is we just got to extract this from the rest of the model. I'm going to do that using this face binder, and this is a draft workbench face binder as opposed to the part workbench face binder, but it works very similarly. So I will click that, and now you can see I've got this face here, and this is just the cross section of that particular T-slot. So now I should be able to delete the T-slot, and it gives us a warning, but it's okay. And this face binder here now sits on its own, right? And all we have to do is head over to part design. I'm going to wrap this face binder in part design just to make things easy. And created a body there, and I'll move the face binder underneath this, and we should be able to delete the original part. Okay, so now we've wrapped the face binder in part design, and we can come over here and grab the extrude tool, add, Oops, looks like it did not like that. We might have to leave the original face binder here. So pad that, and looks like it's going in the other direction, which is okay. So this is a field, right, where we can obviously change the length, but going in and editing this field is too much work, in my opinion. We want a simpler way of doing it. So I'm going to come over to the workbench of spreadsheet, and I'm going to make us a spreadsheet, and this spreadsheet is going to contain the length of the pad. Now this might seem a little bit crazy, but if you've got a lot of these parts, you don't want to have to go hunting through, which particular body it is. If you've got a custom part that's got, 100 bodies, for instance, you don't want to go hunting through to figure out which body's got your pad on it. So what I'm going to do is I'm going to give this a label. We'll call this length, except I spelled length wrong. And this will be a number, and I'll just pick 40 for an example. And we'll come up here and we'll give this cell an alias of length. And that time I spelled it right. And you'll see now that this cell here is highlighted in yellow. That is because it is represented by this alias. And we can extract this alias and put it into the pad here. If we edit this pad, we come up here, there's a little function button there. Click that, and we can go the spreadsheet dot length, length being the alias. Okay, and now you'll see that this here has evaluated to 40, which is identical to our spreadsheet. We click OK on that. And if we come back over here to our spreadsheet and we change this to, for instance, 100, and then we head back over to our part, you can see that it is now 100 long. So this is how I would go about getting these custom length T-slots. The couple of downsides to this is that this does not preserve the original part that this is being cut from. So I will make another video going over a way to do that. It uses a different process. But if you're not particular about what exact McMaster-Carr T-slot this particular section of T-slot is being cut from, for instance, like this particular section, let's say it's 6 inches long, it could be cut from a 1 foot section or a 2 foot section or a 3 foot section, or maybe it's cut from, a silver anodized piece of T-slot or a black anodized piece of T-slot. Those not like those properties are missing in this particular section, so you'd have to keep track of them elsewhere. So this does not keep track of that. All this does is it makes you a part that's easy to use. And what I would do is I would save this part as, let's say, a template. And then anytime you go and you make a custom part from this part, I would save that part as a custom part, just in case you want to go back and edit anything. If you want to, like, for instance, drill a hole through this T-slot here, that would only affect your custom part, and it would be updated through all of your links, but it would not affect the original template part. And I think that's exactly what you would be looking for. So that is the end of this video. I'm just going to quickly go through and align this with the origin if you want to sit with that or sit through that with me, because this is a little bit annoying, just ever so slightly above the origin. So feel free to click off, but this will only take a moment. I'm going to switch over to part design and get myself the measure tool, and I'm going to measure from here to the origin, and I want to measure to the XY plane. And let's see, for whatever reason, it's not liking that. So let's close out of this, come over here and show the XY plane. Oops. Let's see, for whatever reason, my XY plane is in fact not showing up. So let's see, how do we go about doing this? Measure between here and XY plane. Does not like that. We might have to get creative. So I'm going to create a sketch, sketch on the XY plane, of course, and I'm just going to add myself a line, and we'll see if it'll let me measure to this line. Apparently it does not like measuring to a plane, for instance. Measure between there and this line. So it does let you do that, and it appears we are 1.2 millimeters too tall. I probably messed up my decimal place conversion by a little bit, and that's what this is. So I'm going to delete this sketch because it was just temporary, and I'm going to, let's see, I'm going to shift this base feature. Let's see, this face binder here, I need to shift position the Z of minus 1.2. Alrighty, and we might have to come in here and recompute this one. Let's see where that shape binder ended up. Is this a face binder? So the face binder is in fact on the plane, but this this base feature does not appear to be. How interesting, how interesting. Well, for instance, we can just quickly redo this pad. And we do need to reattach the pad face. Oops. Let's see. Cancel on that. The pad face. Profile here is hide that. I'll show this one. And profile here, this face. This is, I guess, just called base feature. So should be able to just click base feature there and have this update. Still is not taking it. I'm not sure. It's probably just easiest to put the pad back in. And okay, well, it appears that our base feature here is the face binder, but it does not take into consideration the face binder's movement. Kind of interesting, kind of interesting. So I suppose we can give this a group with transforms, maybe? Nope. Let us see. I suspected this was going to be easy, but it appears that it is much more difficult than one would think. So let's get rid of the base feature. Okay, we'll come over to the face binder and we will grab a shape face binder. Okay, and if we look at this shape face binder here, it should be on the surface. It appears that when you take the face binder and you drag it onto the body, it forgets its placement. So interesting thing to keep in mind. I was not aware of that, but should be able to take this pad here and change this to be shape binder. Let's see, and I will use this move object after other object to oops. Looks like we got a core dump. So maybe somebody can think about what this means. But let's open up FreeCAD again. And I guess we'll just very quickly run through this again. It is possible I will spell length correctly both times this time. And we'll get to see how good FreeCAD's crash protection is there. Now let me go in here and fix length or length. Okay, now that length is fixed, we can rest safely. So get rid of the base feature, get rid of the pad, face binder. We are going to be referencing using a blue binder here, and I'm using the blue binder so that it doesn't update. There's not really any particular reason for this, but the blue one seems to work. I suspect the green one would be identical. And if you don't know what the difference between the blue and green part design face binder is, there's not much difference. It's very small. It's just whether your part updates as the part that it's bound to updates. So like if you're using the blue one and you move two parts that are referencing each other, the references won't update. You actually have to change the part itself. Whereas the green one, they will update. So for instance, if you use the blue one to line up your holes, and then you moved the thing, that your holes are on, the holes wouldn't move. But if you use the green one, they would. And maybe I'll describe that more later. So spreadsheet.length once again, okay. And I believe that is correct. We have it at the origin, I suspect. This is on the origin, so yes, it does appear to be at the origin. So we'll call that done. And real quick description on the blue and the green face binder is, imagine I have, let's say a metal plate here, right? And then I've got, like, let's say a circuit board, and it's got some holes in it, right? If I on this second plate here reference using I reference the holes using the blue face binder, right? They will look good, but then if I move my plate over here, the holes will stay in the same spot. And if I actually go in and I move the holes around on the plate, they will move. Like if I had an extra hole there, it'll show up here. But the holes will act as if the plate is still lined up directly above with the blue face binder. And the green face binder, if you use the green face binder, the holes would actually move with your part. So you can pick whichever face binder you want, depending on whether you want stuff to move when other things move, or whether you want it to not move. So small difference, big effect though, big effect. So thanks for watching. Thanks for sitting through my struggle bus, and I hope you have a nice day, and I hope you've learned something from this video. Let me know.